What's up, guys? Hope you noticed the fish is gone. He died. All right, moving on. 4.4, the determinant of matrices. That's what this is about. I'm sorry about the fish. I just ruined some of your days. That's okay. 4.4, the determinant of matrices. Now, the determinant is not the same as addition or subtraction or scalar multiplication or multiplication of matrices like we've been seeing in the last couple of videos. This is about the determinant, okay? Now, the determinant is something that we use in order to solve systems of equations of multiple variables, 2 variables, 3 variables, 4 variables, etc. So you're going to see in this video how to find the determinant of matrices in 2x2 and 3x3 matrices. Now, just to give you a heads up, in order to do the determinant of matrices, we must have a square matrix. Now, what I mean by that, as we've said earlier, a square matrix is a matrix with the same amount of rows, 1, 2, as columns, 1, 2. So it must have the same amount of rows and columns to be a square matrix. If you have that, then you can do the determinant of that matrix. So let's just double check, and yes, we see here this is a 2x2 matrix. Okay. Now, all matrices are written something like this. So A is written as little a, B, C, D, and these are just whatever the entry is right there. Okay. Now, in order to find the determinant of A, you're going to write down here vertical lines, bars like that. Okay, you make sure you do that. You're a mathematician. Yes, Travion, you're a mathematician. Michael, Uwe, sit up straight, stop falling asleep. Leon, Max, good kids. Okay, so the determinant of A, okay, you would write it like this. So you're going to find you're going to put the bars like so. Okay, now the determinant is when you actually get this. You're going to get A times D, and you're going to subtract C times B. Now, this is only true for a 2x2 matrix. When we get to a 3x3 matrix, we're going to do something a little differently. In the 4x4 matrix, you're going to see. But what we're going to do here for a 2x2 matrix, this is the pattern you're going to use for a 2x2 matrix. Okay, so if you have the matrix A, B, C, and D, to find the determinant, you take A times D, and you subtract C times B. So what we're going to do is take this times this, subtract these two when you multiply them, and that will be the determinant of your matrix. Okay, so let's do this here. The determinant of matrix A is going to be equal to, bars down like that, 0.2, 30, negative 0.3, 5. Yes, I know that there are negatives and decimals. Don't cry. So here we go. This is going to equal, like we said, it's going to be A times D minus C times B. Well, here's a cool little trick that you can do in order to remember this. You take these two and you multiply them. And then you're going to take these two and you're going to multiply them. And if you remember when we do cross multiplication, this is not cross multiplication, but when we did cross multiplication, Travion actually said last year, that's the butterfly thing. Well, we're going to do something like that. And it looks like a cool butterfly. Look, oh, pretty. So what we're going to do is we're going to multiply 0.2 times 5, and we're going to subtract negative 0.3 times 30. So let's do that right now. So you're going to get 0.2 times 5, and you're going to subtract negative 0.3 times 30. Okay. Well, 0.2 times 5, you're probably grabbing your calculator. Don't do that. This is going to equal 1. We do that in our head. 2 times 5 is 10. Carry the 1 decimal. Okay. Now, this is going to be negative times a negative, so this is going to become a positive. It's negative times a positive. This is a positive. And we're going to get 0.3 times 30, which is 9. So 1 plus 9 is my determinant. So the determinant of A is equal to 10. And that's going to be our answer for the determinant of our matrix A. Okay? So this is true for all 2x2 matrices. This is how you do a 2x2 matrix and its determinant. So if you need to double check, go back and rewind that and see how we're doing. We're going to do an example right now. I'm going to make up this matrix, matrix B, and we're going to do the determinant of this matrix. Okay, so here's my matrix B. It equals 1/2, 1/8, 4, 2 pi. I know. Okay, so let's do this. Stop crying. We'll be fine. The determinant of B is equal to, we can do the big bars, 1/2, 1/8, 4, 2 pi. Okay, So let's think about this. Let's get out our other colored pens to remind us. We're going to do 1/2 times 2 pi, and we're going to subtract 4 times 1/8. Well, what do we get? 1/2 times 2 pi minus 4 times 1/8. Okay, well, what is 1/2 times 2 pi? It's half of 2 pi, which is just pi. And then minus 4 times 1/8. Now, some of you are probably sitting there thinking, Mr. Blair, I do not remember how to multiply fractions. Well, here's a quick little review. Here we have 4 times 1/8. Well, 4 can be written as 4 over 1. So 4 over 1 times 1 over 8. And you multiply the numerators times each other. Don't say top and bottom. We multiply the numerators. We get 4. And we put that over the denominators being multiplied. 1 times 8, which is 8. So 4 over 8, which you guys are smart cookies, and you know is 1/2. So my answer for the determinant of B is going to be pi minus 1/2. And this is the determinant of B. Okay, so that's the idea of finding the determinant of a 2x2 square matrix. Remember, you must have a square matrix in order to find the determinant. Now, what we're going to move into right now is a 3x3 determinant. So let's take the matrix M, 2, 4, 1, 5, 2, 3, 1, 4, 8, and we're going to find its determinant. I'm going to show you two different ways to do this. The first way is what I've been used to doing, and I think the reason why I do this is, one, because of the way I was taught, and two, because I'm used to using matrices with far greater variables and far more rows and columns. However, it's not necessarily the best way to do it, so the second way is actually more preferred from most of my students. A lot of my students like doing the second way. So I'll show you the first way, and you might want to use it whenever. Let's double check if this is a square matrix. 1, 2, 3, 1, 2, 3. So it's a 3x3 matrix. So we're good. We can find the determinant of this matrix. Okay, now here's the tricky part. In order to find the determinant of my matrix M, it's going to equal, again, we were going to write this properly, 2, 4, 1, 5, 2, 3, 1, 4, 8, like so. Okay. And this is going to equal, and this is what you're going to do. You're going to take this number here, top left number, you're going to go left to right, the way we read, and you take this number 2, and if you were to block out that column that is in, and that row that it is in, you would find that it has a 2x2 matrix. Okay? So if you notice that, we blocked out the column that it's in, and we blocked out the row that is in. So the way we're going to do this is we're going to take 2 and we're going to multiply it by the determinant of the matrix that it created by blocking out its row and column. So it's going to become 2 times the determinant of 2, 3, 4, 8. Okay. So again, let's check that out. We took this first top left one and we blocked out its row and column that it falls into, and we found a 2x2 matrix that it has when you block out the other things, and it's also square when you do that, and we get the 2 times this determinant. Now we're not done, because we also have this number here, 4. Okay, so we're going to subtract 4. Okay, so it goes positive, negative, positive, negative, positive, negative, and that's the pattern that you're going to do no matter how huge your matrix is. So you're going to get minus 4 times the determinant of the matrix that when you block its column and its row out. So check that out. We have this here. When we block out 4, we're going to get 5, 3, 1, 8. Okay. So again, let's look at that. We have this number 4, and we're multiplying it times the determinant of when we block out its row and column, like this. All right. And then we're going to add that to, okay, so we're going positive, negative, positive. Now, by the way, if this had been a negative number right here, this would have changed the sign on this, okay? So it's negative whatever that number was, So we're going to multiply this, or excuse me, we're going to add 1 times the determinant of the 2 by 2 that it creates when you block out its row and column. Now notice that this is just going to be plus 1 times that. So really all you're doing is the determinant of the 2 by 2 matrix that it has. So if we block out its row and its column, we're going to get that 2 by 2 matrix. So 5, 2, 1, 4. Okay? And that's it. We're going to do the algebra on this pretty quickly, and you'll be able to do this now for any 3 by 3 or larger matrix. And the problem is if you get 4 by 4s, you're actually going to find that you're going to get a 2, and then you might have a 3 by 3 matrix down here, and you're going to continue doing that. So you're going to have a lot of matrices that you need to do, and that's why calculators are wonderful, but also that's why we have another trick that I'm going to show you right after this. So we're going to get 2 times the determinant of this matrix here. Well, it's going to be 2 times 8 minus 4 times 3. Okay, well, 2 times 8 is 16, minus 4 times 3 is 12, so 16 minus 12 is going to be 4, and this will become minus 4 times the determinant of this matrix, which is going to become 5 times 8 minus 1 times 3. Well, 5 times 8 is 40. I'm doing all these in my head, by the way, so if I make a boo-boo, whoopsie. 5 times 8 is 40, minus 1 times 3 is going to become 40 minus 3 is 37. That's going to be fun. And then we're going to add this to 1 times whatever this is. I'm not going to include the 1 because I don't need to. But it's going to become 1 times 5 times 4 minus 1 times 2. 5 times 4 is 20, minus 1 times 2, which is 2. So 20 minus 2 is 18. So let's simplify this. We're going to get 8 minus 4 times 137 is, what is that, negative 148. And then we're going to add that to 18. And so what we're going to get here is negative 122 is the determinant of my matrix M. Now obviously I do the algebra a little more quickly than some of you guys, and that's okay. You can use a calculator, do as you desire. That's to find the determinant of matrix M. That's using a 3 by 3. Now, let us do another way to do this problem. And I'll show you another trick right now. So we're going to do the same matrix. We're going to find the determinant of M. So we've got this written down. And we're going to do 2, 4, 1, 5, 2, 3, 1, 4, 8. So we know my answer should be negative 122. We know that. So let's do it a whole nother way. Well, what I want you to do is to rewrite the first and second column just like this here. You're going to rewrite the first and second column. So this is the first column and this is the second column. You're going to rewrite it right next to it. So 2, 5, 1. All right, sorry about that. I was interrupted and I screamed at a student. Don't worry, they're still alive. So we wrote down the same column right next to it, 2, 5, 1, and we're going to do that again, 4, 2, 4. So just for the first 2 columns, you rewrite them here. Okay. Now this is the trick in order to find the determinant. This is what you're going to do. You're going to, kind of like when we did the 2 by 2, you're going to take these guys and you're going to multiply them together. So you're going to get 2 times 2 times 8, and you're going to add that to, when we do this now, 4 times 3 times 1. And you're going to add that to 1 times 5 times 4. So you see in the little pattern here we're doing 1 times 5 times 4. But remember, as we did earlier, we had to subtract something. So we are going to subtract the quantity of, well, we're going up now. 1 times 2 times 1. 1 times 2 times 1 plus 4 times 3 times 2 plus 8 times 5 times 4. So let's do it. Let's see what we get. We should get negative 122. 2 times 2 is 4 times 8 is going to be 32 plus 4 times 3 is 12. Plus 1 times 5 times 4 is going to be 20, minus this quantity here. 1 times 2 times 1 is 2, plus 4 times 3 times 2 is going to be 24, and the video is going to end. Sorry.